All right, page number 3. So when we are sketching the polynomial, we need to know a few things. First, I want to talk about end behavior. So if you look at the degree of the polynomial, we have a third degree and we have a first degree. So 3 plus 1 is 4. Hold on, let me make sure it's writing. Perfect. So this is a fourth degree and it is positive. So when we think about a positive fourth degree polynomial, we know that when it approaches negative infinity and positive infinity, it is going to be increasing. Let me just go ahead and mark up my axes. So like positive 1, positive 2, negative 1, negative 2, 1, 2, 3, 4, 5, 6, 7, 8. All right. So I know that I have a triple root at positive 2. So when it crosses through, or when it passes through positive 2, it is going to snake. And I also know that it has a single root at negative 1, so it's going to pass through negative 1. When you multiply this polynomial out, you will find that your constant term is negative 8, which is your y-intercept. So negative 8 is your y-intercept. So I'm going to connect my points. So I have my polynomial. It is going to cross at negative 1, come down, pass through my y-intercept, and then here it is going to snake and go to positive infinity. So it crosses and it snakes. Okay, for the next one. So here I have a double root. I have a fifth root. So let's talk about the fifth root for a second. The behavior of that is much like a triple root. Because if you think about what a fifth degree polynomial looks like, it looks much like a third degree, but with more terms. So if we add up the degrees, I have 2 plus 5 is 7, plus 2 is 9, so that is odd. It's ninth degree, and it's positive. So if we think about what a odd positive looks like, it is going to, what the end behavior looks like, it's going to look something like that. So there's my starting point for my graph. All right, so let's go ahead and mark up our graph. When you multiply out this one, your y-intercept is going to be very, very small. So I'm not going to worry about marking it exactly. I'm just going to go way below. So let's see, negative 1, negative 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5. All right, so let's see what is going on here. So there is a double root at negative 3. So I know that it is going to touch or bounce at negative 3. Then at positive 1, it is going to snake. And at negative 7, it is going to touch. So if I look at my end behaviors, I come up here, I'm going to touch at negative 7. I'm going to touch at negative 3. I'm going to come all the way down. I'm going to come back up. It's going to snake. And there we go. Not the prettiest graph, but you should get the point. I'll just make a note here that this is the snake or the squiggle, however you want to think about it. All right, last one. So let's go ahead and add up the powers. So I have 3 plus 1 plus 2. That is 6. So this is even. And this is negative. Sorry, even negative. I know my end behavior, it's going to be decreasing. So I'm going to put that there just so I know, make sure that my graph ends up looking how it should. So now let's look at, needs to go all the way up to positive 8. 1, 2, 3, 4, 5, 6, 7, 8, and negative 1. All right. So let's talk about what is happening here. So at 8, it is going to snake. At positive 4, 1, 2, 3, 4, it is going to cross. And at negative 1, it is going to touch. So negative 1, it is touching. at positive 4, it is crossing. And then at positive 8, it is snaking. There we go. And we don't know exactly what happens here or what happens here unless we use the graphing calculator. So that is a sufficient graph. Okay, number 8. Write in standard form. Then list the possible irrational zeros of the function. So standard form, remember, is your highest exponent down to your lowest. So standard form for this polynomial is going to be highest exponent is 4. So f of x, negative 6x to the 4th. Then we have 3 plus 8x cubed plus 3x squared minus x plus 15. Now it's important that we do that because when we are listing all the possible irrational zeros, we have to take our p, all the factors of p, and divide them by all the factors of q. And unless it's in standard form, you may mess that up. So possible zeros, I have plus or minus p over q. So that results in plus or minus. My factors of 15. 15 times 1, 5 times 3 over 6 times 1, 2 times 3. So all my possibilities, I'm going to take 15 and divide it by everything. So I have 15 over 6 plus or minus 15 over 2. Sorry, I skipped 1, but plus or minus 15, there we go. 15 divided by 3 is 5. Now I'm going to take 1 and divide it. So I have plus or minus 1/6, plus or minus 1, plus or minus 1/2, plus or minus 1/3. Then I'm going to take 5 and divide it. So I have plus or minus 5 over 6, plus or minus 5. But remember, I have it right there, so I don't need to list it twice. Right there. So then the next one would be plus or minus 5 over 2, plus or minus 5/3. And then lastly, I need to take 3 and divide it by everything. So I have plus or minus 3/6, which is 1/2, but I already have that right here, so I'm not going to worry about repeating it. Plus or minus 3 over 1, I already have, no, I don't have 3, so plus or minus 3, plus or minus 3/2, and then plus or minus 1, which I have. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Am I repeating 1? No, I'm good. All right, now for the next one. Find the zeros of each equation using the given zero. So if it's giving me a 0, and this is a third degree function, then I'm going to want to use synthetic division or long division if you write it as a factor to get it to be a second degree. Why? Because then we can factor. So here we have -2, and I have 1, negative 12, -23, and 10. So it tells me that it's a given 0. So I know that when I'm done with synthetic division, my remainder is going to be 0, if I've done everything right. Bring down the 1. -2 times 1 is -2. So that's -14. And I have 28. And then I add, so I have 5. -10 with a remainder of 0. Okay, now I have a second degree polynomial. So I have x squared minus 14x plus 5. So now think to yourself, well, can I factor this? Let's see, two numbers that multiply to give me 5 and add to give me -14. No, I do not. So then I have to use a quadratic formula. So my a value is 1, My b value is negative 14, and my c value is 5. So when I do the quadratic formula, I have plus or minus negative b. Nope, sorry, it's not plus or minus. I have negative b plus or minus the square root of b squared minus 4ac all over 2a. And that will be given to you on the test. So when we simplify, I have 14 plus or minus. See, 14 squared minus 20. That will give you 176 all over 2. You can simplify the square root of 76. That is 16 times 11. Oh no, I'm running out of room. So I have 14 plus or minus 4 square roots of 11 over 2. Now we always want to leave answers in simplest form. That simplifies. You can divide 14 by 2 and plus or minus 4 by 2. I'll change the color. So that results in 7 plus or minus 2 square roots of 11. So when we are writing our solutions, don't forget the one that was given to us. So we have x equals, just going to write it as a set, negative 2, 7 plus or minus 2 square roots of 11. So there we have 3 solutions right there. My power is 3, so I know that I'm good. That is my final answer. All right, so now for B. It tells me that a 0 is 3, so I'm going to go ahead and use synthetic division. Now remember, when I'm done with synthetic division, I will have a 3rd degree polynomial left, because it always drops a degree when you do synthetic division. So I have 1, negative 13, 7, and 42. If it's a 0, my remainder should be 0. So I have 1, or it will be 0. 3, negative 2, negative 6, 3, negative 2. Sorry, that's positive 2. Positive 6. So that's negative 7, negative 21, negative 14, negative 42, and 0. Perfect. Now I have x cubed plus 2x squared minus 7x minus 14. So at this point, you can do synthetic division again by finding all the possible ones. So plus or minus the factors of 42 over 1. Or if you look closely, you can do factor by grouping. I know I always tell you do it until 2nd degree, but if you catch that you can factor, then always factor. If you find the possible and then continue with synthetic division, you will eventually get it down to a 2nd degree and be able to factor it using the quadratic formula, but it just may take a little bit longer. So whenever we have 4 terms, we can do factor by grouping. So I'm going to just group together 2 of my terms, and I look for the greatest common factor. Greatest common factor is x squared, so that leaves me with x plus 2. Now look at my second set. I can factor out a negative 7. So my greatest common factor is negative 7, so that leaves me with x plus 2. Notice how those are the same. So I combine my factors on the outside, and I keep the factor that's the same. So here we have it. I'm going to set it equal to 0 and solve. So I have x squared minus 7 equals 0, and I have x plus 2 equals 0. So x equals plus or minus the square root of 7, x equals negative 2, and then I have the 0 that I'm given is x equals 3. So that's 1, 2, 3, 4, and those are all my zeros. So x equals, you don't have to write your answer like this, but it's preferred. All right, so there we have it. Done with B. So now we are going back to what we learned last unit. Find the domain for each expression. So if we are finding the domain, if it's a square root, remember, I cannot take the square root of a negative number because that results in an imaginary solution. And also we want to look at this right here. So it's a second degree polynomial. So that means the first thing I have to do is factor it. So I'm going to use factor by grouping. I need two numbers that multiply to give me negative 12 and add to give me positive 11. So I'm going to split that middle term into 4x squared. So that would be positive 12x and negative 1x minus 3. Now I'm going to group together two of those, any two, doesn't matter which ones, and take out the greatest common factor. So that would be 4x, and I'm left with x plus 3, and then negative 1, which results in x plus 3. So then my factor is at 4x minus 1, and x plus 3. Now that I factored it, I'm going to set my factors equal to 0. So I have x equals positive 1/4 and x equals negative 3. All right. So whenever we are solving or say the domain with a quadratic function, we always have to test the points. So if I draw a number line and I write my solutions, negative 3 and 1/4, I need to test each section to see if it's true. So first let's go ahead and I'll test 0, which is right here. So I'm going to go back to my original and substitute it in. So I have 4 times 0 squared plus 11 times 0 minus 3. Now what we're looking for here is if it results in a positive or a negative number. Let's see, I have 0 plus 0 minus 3, so that's negative 3, so that results in a negative number. So that means that this middle section cannot be part of my solution. Now I'm going to pick something higher than 1/4, so I'll just go ahead and pick 1. So I have 4 times 1 squared plus 11 times 1 minus 3. So let's see, 1 squared, that's 4, plus 11, that's 15, minus 3, that's 13, so that's positive. So yes, this section checks out. Now for a value that is less than negative 3, I'll go ahead and pick negative 4. So I have 4 times negative 4 squared plus 11 times negative 4 minus 3. So that is 4 times 16 minus 44 minus 3. If you take your calculator or do it by hand, that results in a positive answer. So now I can write my domain. So my domain is going to be negative infinity to negative 3. It can include negative 3 because you can take the square root of 0. Then 1/4 to infinity. You have to test the point so you know what is included and what is not. All right, now for B. So for B, same thing, we need to factor, but this time there are two parts to it. There's a rational part of the function and there's a radical. So let's look at the radical first. So I'm going to do that in blue. So again, we need to factor. Well, when we factor that, that's a difference of squares. So I have x minus 6 and x plus 6. Now I'm going to test points. So set this equal to 0. I have a negative 6 and I have positive 6. So when I test them, if I test a point 0, let's see, 0 squared minus 36, that's negative 36, that does not work. If I test the value 7, let's see, I have 7 squared minus 36, yeah, that results in a positive number. So I'm good there. Now let's try negative 7. Well, if positive 7 works, and negative 7 will also work because we are squaring that value. So now for the rational part, it can be anything from negative infinity to negative 6 and 6 to positive infinity. But remember, for the rational part, it cannot equal 0. So if there's a 0 in the denominator, then it will be undefined. So what does that look like when you combine the two? Negative infinity to negative 6 with a parenthesis, and 6 to infinity. So again, I use parentheses because if it does include the 6, then it causes there to be a 0 underneath the radical, which causes there to be a 0 in the denominator. So that's why we don't include them. All right, that is it for